Imagine this. An object from beyond our solar system hurtling through space at incredible speed, passing so close to Earth that we almost missed it. What if that object, 3I, Atlas, shouldn't even exist? An interstellar traveler, behaving in ways we simply can't explain. In July 2025, astronomers spotted something unlike anything they'd ever seen before. 3I Atlas is the third interstellar object ever detected, but its behavior has left scientists scratching their heads. Instead of acting like a typical comet like we'd expect, it's been defying every prediction. Its speed, its trajectory, and even the way it moves through space seem to break the rules of what we thought was possible. What is it about this object that's so strange? What makes 3I Atlas so fascinating, and why are scientists so eager to study it? As we delve deeper, we'll explore not only the data, but the theories, some strange, some extraordinary, that could explain its unexpected behavior. Is this just a comet that has traveled across galaxies, or could there be something more to it? Let's begin this journey and uncover what makes 3I Atlas one of the most mysterious objects to pass through our solar system. In July 2025, a discovery made by the Atlas Survey Telescope in Chile sent shockwaves through the scientific community. The Atlas system, designed to detect near-Earth objects, had been scanning the skies as usual. But this time, it flagged something out of the ordinary, a fast-moving object traveling at an incredible speed. The object was identified as 3I Atlas, an interstellar comet. But what made this so special? 3I Atlas was unlike any object we'd seen before. It wasn't just a comet traveling through the solar system, it was the third known interstellar object ever detected. Only two other objects, Oumuamua and Borisov, had made similar journeys, and both had raised their own mysteries. But 3I Atlas was different. It was moving faster and traveling from farther away. At the time of its discovery, the object was already on a trajectory that would carry it through our solar system at 58 kilometers per second faster than any comet we had ever tracked. The initial analysis showed its speed and path were far from normal. Unlike typical solar system comets, its movement wasn't influenced by the sun's gravity the way we'd expect. Its speed and the way it was defying the gravitational influence of the sun set off alarms in the scientific community. Scientists immediately turned to their best instruments to track this enigmatic object. The Green Bank Telescope and the Deep Space Network were quickly engaged, each playing a pivotal role in tracking its path through space. But as the data began to roll in, it became clear that 3I Atlas wasn't behaving like a typical comet. Its trajectory was puzzling, and scientists couldn't explain the data they were receiving. The discovery of 3I Atlas wasn't just another astronomical finding, it was a breakthrough, raising questions that no one could answer. Its strange speed, its unexplainable trajectory, and the very nature of its existence left scientists intrigued, eager to uncover the secrets behind this mysterious visitor. Once 3I Atlas was discovered, scientists scrambled to gather as much data as possible. Observatories and telescopes worldwide turned their attention to the object. Among the key instruments were the Green Bank Telescope, which provided crucial radio data, and the Deep Space Network, which helped track the object's movement. But the most significant contributions came from the James Webb Space Telescope, which captured detailed spectral data from 3I Atlas, and the Allen Telescope Array, which searched for any signs of artificial signals. When the first data came in, scientists expected 3I Atlas to behave like a typical comet, a ball of ice and dust that would gradually brighten as it neared the sunday. What they found was something entirely unexpected. Instead of the usual steady outgassing of gases like water vapor, 3I Atlas was emitting gases like carbon monoxide and carbon dioxide in strange patterns. Its brightness was erratic, fluctuating in ways that didn't align with what astronomers had anticipated. What puzzled scientists even more was its behavior in the far reaches of space. Comets generally begin releasing gas and dust when they are around 3 astronomical units from the sun, but 3I Atlas was already exhibiting signs of outgassing when it was still 6 astronomical units away. This early activity raised even more questions. How could an object from interstellar space, potentially billions of years old, be so active? Further studies revealed that 3I, Atlas, had a coma, a cloud of gas and dust surrounding its nucleus that appeared much larger than expected for an object of its size. Its tail, which typically points away from the sun, was instead extending in the opposite direction. This odd behavior led some scientists to wonder if there was more to 3I, Atlas, than met the eye. The data didn't stop there. Spectral analysis showed that 3I, Atlas, had a unique light curve, a pattern of light variations that couldn't be explained by the usual models for cometary behavior. This made it hard for scientists to even categorize the object. Was it a comet, an asteroid, or was it something entirely different? As more data poured in, the mystery deepened. The initial scientific expectation was that 3I Atlas was simply a comet, but its strange outgassing, erratic brightness, and mysterious trajectory painted a far more complex picture. Could this really be just a comet? Or was there something else at play here, something that scientists have yet to fully understand? With the data in hand, scientists began to develop theories to explain 3I Atlas's strange behavior. The most common explanation was that it was a comet, an interstellar traveler that had been ejected from its home star system millions of years ago. This natural theory suggested that 3I Atlas was simply a comet on a very long journey through space, but the anomalies in its behavior made this theory harder to support. As scientists examined the data, they found that 3I Atlas wasn't behaving like any comet they had ever seen. Its erratic brightness, the strange gases it was emitting, and its unusual trajectory made the comet theory seem incomplete. This led some astronomers to propose an alternative explanation that 3I Atlas could be artificial in origin. The idea that 3I Atlas might be an alien probe sent from another civilization to explore our solar system has sparked much debate. Proponents of this theory argue that the object's strange behavior, its unexpected trajectory, its unusual outgassing patterns, and its erratic movement suggest that it could be a piece of alien technology rather than a natural object. However, this theory faces significant challenges. First, there is no definitive evidence to support it, and no signs of advanced technology have been detected. Additionally, the trajectory of 3I Atlas seems to align with natural forces, suggesting that it might be following a predictable path for a comet or asteroid. Yet the possibility that it could be alien technology still lingers in the minds of some. Both theories, natural and artificial, have their flaws, and neither fully explains the object's unusual behavior. Could there be another possibility? Some scientists have speculated that 3I Atlas might be a fragment of a much larger object, perhaps part of a comet or asteroid that broke apart long ago. The pieces could have traveled across the galaxy, eventually arriving in our solar system as this strange object. Ultimately, the truth remains elusive. The more scientists learn, the more questions arise, and the mystery surrounding 3I Atlas deepens. Whether it is a comet, an alien probe, or something else entirely, one thing is certain: this object is far more than we initially thought. In March 2026, 3I Atlas will make its closest approach to Jupiter, and scientists are eagerly anticipating this event. As the object swings by the gas giant, they hope to gather more data that will help them understand its behavior and origins. The Jupiter flyby will provide a rare opportunity to study 310 Atlas in detail as it passes through the gravitational influence of the planet. Scientists will be watching closely to see if 3I Atlas follows its predicted path or if something unexpected happens. Will its trajectory remain as expected, or will it deviate in ways that force scientists to reconsider their theories? The flyby could provide crucial insights into the object's composition, its speed, and the forces acting on it. If the object behaves as expected, it could provide a clear confirmation of its interstellar origin. However, if it deviates from its predicted path or exhibits new unexplained behaviors, it could prompt a complete reassessment of our understanding of interstellar objects. This flyby could be the key to unlocking the final pieces of the puzzle surrounding 3I Atlas. What scientists learned during this event will likely shape our understanding of this mysterious object and could even lead to groundbreaking discoveries about the nature of objects from other star systems. 3. I Atlas has captivated the imagination of scientists and space enthusiasts alike. From its unexpected discovery to its strange behavior, this interstellar object has left us with more questions than answers. Is it a comet from another star system, or could it be something much more extraordinary? The theories are many, but the truth remains elusive. As we look ahead to the Jupiter flyby in March 2026, there is hope that this event will provide the answers we've been searching for. But even then, the mystery of 3I, Atlas, may only deepen. Could it be a sign of something bigger, something we're not yet ready to understand? The investigation into 3I, Atlas, is far from over. Each new discovery raises more questions, and each answer seems to reveal a deeper mystery. What we've learned so far is only the beginning. As we continue to observe and study this mysterious interstellar object, one thing is certain. 3I, Atlas, will continue to challenge our understanding of the universe and what lies beyond.